The last two planets in our outer solar system are Uranus and Neptune. These two planets are very similar. Both planets are classified as gas giants. They have similar overall appearances, have many moons, faint rings, and are very cold. While they have similar atmospheric compositions, there is a difference in their overall density. Uranus is slightly larger in diameter, but Neptune is slightly more massive. Each planet presents some unique characteristics as we consider their roles in our solar system. First, Uranus is a sideways planet. Where Jupiter's poles have only a very slight tilt of degrees, and Earth's axis is tilted 23.5 degrees, Uranus is tilted about 98 degrees from vertical. This extreme planetary tilt means the sun's light shines directly on the polar regions for much of its orbit. Since the planet rotates in this sideways fashion, each hemisphere experiences constant daylight, 1/2 of its orbit, which totals 84 Earth years. When we consider the most distant planet, Neptune, we find that it has a highly active atmosphere. While Jupiter's winds reach speeds of 400 miles per hour, Neptune has the highest atmospheric wind speed in the entire solar system, reaching speeds nearly 1,200 miles per hour. Like all of the gas giant planets, Neptune has a rapid rotation, especially for its size, completing one rotation every 16 hours. Like Jupiter with its Great Red Spot, Neptune also has been observed to host a giant storm. One such storm, observed by the Voyager 2 space probe in 1982, was named the Great Dark Spot. This storm had a size equal to Earth's diameter. In contrast to the persistence of Jupiter's large storm, Neptune's Great Dark Spot has since disappeared. But with violent atmospheric winds, it won't be the last disturbance seen. An additional quirk seen for both Uranus and Neptune is that their global magnetic fields are significantly tilted with respect to their rotation axes. So the poles of the magnetic field are substantially different than the poles of rotation. This contrasting alignment results in both planets having a highly complicated magnetosphere, caused by the magnetic field becoming twisted and distorted as it is rotated onto itself. As we see on Earth, the magnetic field plays a vital role in protecting and shielding the planet from the high-energy charged particles in space. Life on Earth would have serious complications if this type of scenario existed here. Now, when we consider the role these two planets have in our solar system, their existence is forever intertwined. Through history, many civilizations have made note of the existence and the position of the inner planets: Mercury, Venus, Mars, Jupiter, and Saturn. These 5 objects would be known as wandering stars because, although their appearance in the sky was like a star, their movements wandered along different paths. Thus, the discovery of Uranus as a similarly wandering object in 1781 was the first discovery in thousands of years, and it was made possible by the telescopic invention. Uranus became intensely studied over the next half-century. Its orbital parameters were slowly calculated and refined. However, by the early 1800s, astronomers had already noticed that there were significant differences between the calculated and the observed locations of Uranus. Now, the law of gravitation, supplied by Newton, the laws of planetary orbits described by Kepler, had aided astronomers for nearly 200 years to make accurate and calculated predictions of the known planets. Acknowledging that the cosmos is orderly and that it operates through regular functionality, astronomers and mathematicians began calculating and predicting the position of an unseen planet that could be the culprit inducing the differences in Uranus's location. From these precise predictions, the planet Neptune was discovered in 1846. During the creation week, God set laws in motion that governed our physical universe, including the planets. These laws serve as regular and calculable guides to the functioning of our solar system. Utilizing hundreds of years of knowledge from scientists studying God's creation, 19th century astronomers were able to observe and predict clues that led to the planet Neptune's discovery. Uranus and Neptune provide intriguing examples of planetary dynamics and have served well in their role of proving the intelligent design of our cosmos.